everyone. In this video, we are going to discuss the solution for bubble sort. So in this question, we have been given a list of unsorted integers. And what we need to do is we need to sort those integers using bubble sort algorithm. So let's see what the bubble sort algorithm is all about. So here is, we have a list of integers which are unsorted and we need to sort these integers using bubble sort. So in bubble sort algorithm, what we do is we just check our current with previous and see if our current is smaller than our previous. If our current is smaller than our previous, then we swap the elements. If current is bigger than the previous, then we do nothing. Alright, so that's what we are going to do here. So this is our first iteration. Now we are going to check from here. No, we are going to check from our first position, first index, because we don't have any previous for our zeroth element. So we are going to start from our first element. So now what we are going to do, this is our current, this is our previous. So I'm going to check if my current is less than my previous. Is that so? 9 is smaller than 5? No. So we are not going to do anything. Now for second iteration, 5, 9, 7, 8, 9, 1. Now this is my previous and this is my current. Now I'm going to check if my current is smaller than my previous. Yes, my current is smaller than my previous, so I'm going to swap it. 7 and 9 swap places. Now for 1.3 iteration, 5, 7, 9, 8, 1. This is my current, this is my previous. Is current smaller than my previous? Yes, 8 is smaller than 9. So we swap the 8 and 9. Now 5, 8, 9 and 1. Now this is my previous, this is my current. I have to check current is smaller than previous. Yes, current is smaller than previous. And here comes 1 and here comes 9. Now what we got is 7, 8, 1 and 9. Okay, so now you can see our one element is sorted, our last element is sorted. You can see in our first iteration, the biggest element comes towards the rightmost place. Alright, now moving on to our second iteration. Let me move it to smaller place. Okay. Now for second iteration, 5, 7, 8, 1, 9. Okay, this is my sorted and I'm going to start from 1.1. This is my current, this is my previous. Current smaller than previous? No, not going to do anything. 5, 7, 8. Current 1 is sorted. Current smaller than previous? No, not going to do anything. Now 7, 8 and 1. This is my previous, this is my current. Current smaller than previous? Yes, that places. Now you can see that this part is already sorted, so you don't need to go further. So our current will remain till here and we will end the sub loop. Oh sorry, this should be 2 here, not 1. Now for third iteration, we got 5, 5, 7, 1, 8. Last two are already sorted. My 3.1 iteration, my current, this is my previous. Current smaller than previous? No, not going to do anything. Now 3.2, 5, 7, 1. Previous and current 8 and 9 are sorted. Now current smaller than previous, yes, then swap. Now we have 5, 1, 7, 8, 9. This part is sorted. Okay. This is my third iteration, and okay, now fourth iteration, 4.1, 5, 1, 7, 8, 9. This part is already sorted. This is my previous, this is my current. I'm going to check if current is smaller than previous. Current is smaller than previous, so I'm going to swap it. So now my list has become 1, 5, 7, 8, 9. Alright, 7, 8, 9 was sorted, so I don't need to go any further. So here it is. Now we have sorted list. That's what we needed. These are the 4 iterations, and you can see clearly that we had 5 elements. 1, 2, 3, 4, and 5 elements we have, and we did 4 iterations. So it means that that we need to run our loop for n minus 1 number of times if we have n elements. All right, so let's try to code this. All right, now you can see that we have already a swap function and a smaller function. Okay, now what we need to do is we need to use these two functions that we have already declared here, because you can see in our output we have something like this: comparing and swapping, comparing, swapping, comparing, swapping. Okay, something like this, and then we have sorted list. So to get this similar output for the bubble sort, what we need to do is we need to use these two functions, swap function and smaller functions, so that our test cases can pass. Okay, so we need to write a bubble sort now. So first of all, we need to write a loop. So for iterations, I in range, and it should run for length of ARR. Okay, I minus 1 times n minus 1 times, sorry. So n minus 1 times for this is our current x. So for C in range, length of ARR minus I. Okay, so now y minus I, you can see that we were running when we have in first case we were running 4 times, then we were running 3 times, then 2 times, then only 1 times, because that many number of elements were already sorted. Okay, that's what we are trying to do. We're trying to reduce the number of previous and current comparing loop. So that's what we have written. I here minus I here. So if is smaller ARR, I have to pass if my current is smaller than previous was current minus 1. If this was the case, then I need to swap current with previous current, meaning current minus 1. All right, so this is what this is what we are trying to do. So let's run and see if our program was right or not. Okay, missing. Okay, okay. I forgot to send our list. Oh, okay. It is showing me wrong answer. I'm getting sorted. I'm making some mistake here. Let me see. One. All right. I made a mistake that I was trying to start my current from 0. All right. Instead, I have to use 1 because you can see I was always starting from current equals 1. I was starting my current from index 1 always. You can see each time when I was starting, my current was at index 1. That's what the problem was. So now our code has been accepted for sample test case. So then let's run for all test cases. Run and see. All right. Now we got 10 out of 10, which means that our code is correct and a bubble sort algorithm is completely valid. So that's all for this video. And if you have any trouble in understanding bubble sort, I would like to suggest you that you should watch this video again and see its dry run, because dry run is most important while you are trying to understand a sorting algorithm. Okay. Oh, forgot to tell you about one thing. It's time complexity. So you can see that I'm running this loop for how many times? N minus 1 times outer loop and n minus I number of times for inner loop. So you can see clearly that I have used 2 loops. This is running for some minus 1 times, sorry, n minus 1 time. This is running for n minus number of times. Okay, so n minus 1 into n minus I. This many number of times my code is running. So my time complexity is O(n) square for my bubble sort. So you need to remember that time complexity of bubble sort is O(n) square. And as you can see that I have made swapping in, I have done swapping in the same list. So I haven't used any extra spaces. So the space complexity, this is my time complexity. Space complexity will be equal to O of n, meaning constant space. Because I haven't declared any other list to sort my list, so my space complexity is constant. So my space complexity is O of n and time complexity is O(n) square. Alright, so that's all for this video. See you in the next one.